Moving on, if you notice the question, you have been given a vector, right? You have been given a vector form, and in the vector form, you would want obviously to return the answer in the vector form notation as well. What, however, we are getting is a single vector. So, sorry, single scalar. So for 5, yes, the answer is 10, but for the second element, we did not get any answer. And for the third case, -3, the answer is -27. So we are getting answers one by one. What we do want, however, is that if we are giving the MATLAB a vector, and based on whatever conditions, whatever cases are being fulfilled, we should be getting the answers within the vector form as well. So in that case, what I'm going to do is I'm going to take this V outside the loop. I'm going to come out of it, and I'm going to assign, let's say, n variable for the length of V, where length is nothing but uh, 3 in our case, in my case, right? So nr, how many elements? 3 elements, right? Now what I would want is I would want MATLAB to check the V vector, because I told you that V here should be a scalar, right? Since I have taken V outside of the for loop, again V has become the vector here. So what I'm going to do is I'm going to ask MATLAB to run this loop 3 times. How? Because the number of elements are what? 3. So I'm going to ask MATLAB to run this 3 times. In the first pass, the k key value is 1. So it should be reading the V's first element. In the second pass, k's value will be 2. So it should be reading the V's second element. And in the third pass, k's value is 3, so it should be reading the V's third element. So in other words, my values of k are 1, 2, 3. And these 1, 2, 3 I'll be using as element addressing. So coming back to the conditional expressions where I've written V. Now V is no longer a scalar, right? Because it has become a vector, it has come out of the for loop. So in that case, what I'm going to do is I'm going to use this K right here as the address of the vector V. I'm going to say address for the first pass V's first element. For the second pass V's second element, address V's third pass, the third element for the third pass, right? So wherever I have written V, I'm going to add the address of V, which is designated by this loop index variable, and I'm going to get my answer in the vector form as well. So wherever I have used V, notice I'm enclosing the K here as well for array addressing right here. That's it. I'm going to enlarge this view. Fine. Now see, V has how many elements? 3 elements. Now n, because n is only saving the number of elements, is 3. I'll put a suppressor at the end. For k key value 1 colon n. 1 colon n means 1, 2, 3. So in the first pass, k's value will be 1. So we check if V's first element is greater than 0 and the remainder of V's first element with respect to 3 is equal to 0, or remainder of V's first element with respect to 5 is equal to 0, then what you are supposed to do is in the V's first element, what you are supposed to do is modify V's first element by multiplying by 2. Fine. Then if let's talk about second pass where k key value is 2. In that case, yeah, sorry. So V's in the second pass, k's value will be second. So V's second element will be addressed. In the third pass, k's value will be 3. So V's third element will be addressed. So I'm going to show you the result, how we are going to get it, because I have not added a suppressor here. So you'll notice that I'll be getting my result for pass by pass. So here is it. See, for the first pass, only the first element has been changed. So 5 has been changed to 10. 17 remained unchanged, -3 remained unchanged. In the second pass, the V's first element is the same, which was in the first pass. The second element 17 remain unchanged as it is. Why? Because it neither fulfilled this condition nor it fulfilled this condition. As a result, no new value, neither it has been doubled nor it has been cubed. As a result, it remained unchanged. Also notice, because I have used the same variable name towards the left hand side of the assignment operator, 17 remained 17. Fine. Then in the third pass, uh, okay. In the third pass, I'm not getting the second pass result. Why? Because obviously neither this was run nor this was run. As a result, I'm only seeing two answers here for the first pass. In the second pass, obviously it was not run. In the third pass, this is the result for the third pass. In the third pass, obviously the first was had already been reassigned to 10. The second pass result was unchanged, and in the third pass, -3 has been cubed in front of you. Fine. Also, please make note, because you need to minimize the computational time, it is very important that you minimize the number of outputs that you're displaying. So what I'm going to do is I'm going to suppress the intermediate results, intermediate outputs, and I'm going to come out of the loop and I'm going to ask it to display V only once. If you wish, you can use any other output function. For me, the disk function works. It's going to show me the result as it. It's going to show me the result only once like this. That's it. So the finalized version is V's first element has been doubled, second element remained unchanged, and the third element has been cubed. That's it.